Okay, here is question 6a. So the difficult part of question 6, I've left the other pieces as they are because they're straightforward. So if you didn't like using similarity, you might prefer this method. So what Jivani has done is she's worked out the area of the little orange triangle and then of course multiplied it through by the height of the prism to get the volume of that triangle, right? And then she's also added to that the volume of the base. So in other words, this is what they originally gave you. They told you that this length over here was 60, right? So if that's 30 over there, then this length over here is 30 as well. So we know that that's 30 because obviously if the whole thing is 60, that piece must be 30. So initially we're working in this triangle here, this green triangle, right? And what we're going to do is find the size of the angle theta and then use that to find the rest of everything else. So tan of theta is equal to 30 because I'm looking at that opposite over adjacent, which is 80, right? Because the height of this green piece is 80. So tan of theta is 30 over 80, which is 20 odd degrees. Then the area of the triangle we want now is the orange one. So the triangle we want now is this orange one over here. And obviously it's going to be half base times height. This time the base I've decided to call h, and the height I've decided to call q. So this is with the water now at that level, and the water's at the height h. So it's half base times height, so it's half h times q. Now I need q in terms of h so that we can have something sensible here for our triangle. And again, this is the same angle. It's the same angle in the same triangle. That's the opposite. That's the adjacent. So tan of this angle over here gives us q over h. So q is equal to h tan 20 degrees. So the area of the triangle is going to be half of h, as discussed, times by q, and there's q, right? So now we've got the area of the triangle. Then obviously we're talking about a triangle of water like this, but it's a three-dimensional thing, so it's going back. And what we want is we want the volume of that triangle of water. And so the length of this is 120, so the volume of the triangle is going to be half h times this, which is the actual area of this triangle here, times, of course, by the 120, and that is 45 over 2h squared, which you'll recognize as part of what we want to prove. Then we're also going to do the rectangle, so we want to know the volume of the water, and we're talking about a thing that looks like this. So we obviously also want to know the volume of this going through, right? So we want to know the volume of this cuboid going through. And this one is again going to be, it's 30, its breadth is 30, its height is h up to wherever the water is. And then of course you're going to multiply through by the 120, and now you've got the volume of that. And the final volume is going to be the volume of the triangular piece, which is this one, plus the volume of the rectangular piece, which is that one. I don't know if you find this better, but that's an alternative. And so that is question 6a of exercise 8e, and if you don't want to use similarity, this is a method you can use instead.